All right, off we go. So as I sent out with the notice, I've reopened the P3 submission for a short window. I had several stragglers that I've been very graciously willing to accept, and it's just becoming too much of a logistical hassle for me to deal with all the emails separately from the Blackboard submissions. So if you had previously emailed your project to me, it'll only get graded if you submit it now in this window, which is open through tomorrow, I think. I think a large part of that is that despite my best efforts, when I say it'll take you a while to write 1,000 lines of code, you figure I will wait until the last minute. And if you know me, you say, I will wait until the last minute, and then I'll take advantage of Todd's kind heart. So, you now know that the projects take time and effort, and that you don't wait till the last minute. You better be writing code this weekend, because Mr. Nice Todd's going away. And Mr. Grouchy, when the deadline comes and passes, the deadline comes and passes. Todd is emerging from his chrysalis to fly and haunt your dreams. So, yeah, you need to be working this weekend and next weekend on P4, which we'll talk about today. Before I do that, are there any questions about anything? Yep.
Can we submit it again, even if we haven't emailed you?
Yes. Any other questions? Okay. P4, hot off the presses, and in fact the presses are still printing. So I'd said that I'd been changing some things around, and I have been changing some things around. I've been changing things around in the 540 project as well, and these are big projects, and I'm not waiting to the last minute, but I'm having a hard time staying caught up. So I've got most of, between those two, I've got most of this one in place, but not all of it. If I click on this write-up here, at some point you hit a do not go beyond this point. Now you could, strictly speaking, you could go beyond this point until you hit do not do this step yet. What happened was I got to this point, and this is affected by my desire to integrate local variables into the project. And so I need a little more time to look at this very last step before committing to it. All of this stuff you could actually do, but it's a bit of a hassle. I'm using a lot of let me take just half a step back. In this project, we're introducing game objects, triangles, circles, text boxes, pix maps. There are 5 different game object types. And those have classes associated with them where all the code's essentially been provided. And they contain, basically just contain what they are, right? Triangle has an XY location and a color and a bunch of attributes. All of them have various attributes, so it's just pre-written code to manage all those. In trying to massage this stuff that we're looking at on the screen here, I decided what I wanted to do is I wanted to totally rewrite those classes. I don't have time to do that, so what I do want to do is I want to take some member functions in those classes and make them static member functions because it makes your job easier. So you could do it right now, but you have to kind of pat your head and rub your belly at the same time to make the code work. So I would recommend holding off on these 2 steps and give me the weekend to go ahead and kind of fine-tune those game classes to make your job easier and more straightforward here. All right, so that's the deal with that. So here I say Even this is out of date now. It says step 13 to be revised, steps whatever 10 on to be revised. So there are quite a few files provided, and you can actually use all these files as is right now up to step 10, no problem. When I provide updated files, it isn't going to hurt anything. As far as where you get them, you can now click into the P4 project. I've got this zoomed in. Good. And there's the README file you can see, and there's the tarball. The tarball contains exactly what we see in this README here. It'll go into the source. It'll create source in P4 if they don't already exist. At least source should already exist, so make sure you're in the proper directory. So it'll dump it into P4. A side note on the naming of this directory where you're doing your project, the make file actually looks at the name of the parent directory, and it turns on and off a bunch of switches depending on what this directory is. So you aren't going to want to rename it. You want it to definitely be P4. Let's see, we can kind of quickly run through this. So as I said, you need to add support for these game object types. They are as pointers. The closest we have to that is the string class right now. But if I was to look at, let me look at some code here. All right, so internally we're storing, well, I guess we're storing all these, but certainly the string is being stored as a pointer. But when we get it as string, we aren't returning. We're dereferencing. We're doing it for all these. We're dereferencing the pointer and returning the object. So we're now dealing with complex enough types that we're no longer going to be dereferencing and returning the object. So you'll have things like rectangle, pointer, as rectangle. All right. So all these are you're not dereferencing, you're leaving them as pointers. So you're asked to add support for these 5 types to the symbol class. You'll have to do 2 constructors for each. So you'll note that I've got a constructor. Let me pick on double. I've got a constructor for double and another constructor for double that provides a count. So one's for arrays, one's for without. That means you've got 10 constructors to write. And here I'd say that, 2 constructors for each and 2 as functions for each, because if again I pick on double, we have as double and as double where an integer is provided. That gives you a particular double inside an array. All right. So there are quite a few functions you have to write there. Also, in addition to the game objects, there's another class called an animation block. And if you recall, you can create a block of code that's basically used to animate an object. It's tied to a particular object. This code block can be tied to a rectangle, and it'll get called regularly to presumably animate the rectangle. You need to go ahead and throw that one. And after you do the game objects, you basically do the same routine for this animation block class. And let me say print as well. Where do I talk about printing? Oh, yeah. Add the ability to print the different. So I'm sorry, let me back up half a moment. It looks like I kind of skipped 2. The constructor functions for symbol, the as functions for symbol. You have to be, the symbol has this chevron, this insertion operator. You need to be able to support those with the 5 game objects. Those operators are already defined in each of those game object classes. So all you have to do is just throw it into the dereferenced, throw into the chevrons, It's basically as easy as printing out, I say as straightforward as printing out a string. I should say as straightforward as printing out a string given a string pointer, meaning you would dereference the pointer and then print out the string, right? So you have to do that. You're going to have to add the same symbol support for the animation block, the as deref things, the constructors. However, animation blocks never come as arrays, so you do not write an array constructor, nor do you write an accessor as function for the array on animation block. And you need to do printing on animation block. Where did I say? So I bundled printing in here. Animation blocks are quite easy to print out because you print out that word, animation block with the underscore, and then you print out the name of the animation block. Okay, so not difficult either. Now we move to the constants. All that code is sitting in the header file for constant. Here is picking on double again. You have to write one of these classes for each of the 5 game object classes. That means that this list, this list here, I have 3 of those items because I have 3 constant classes in here right now. You're going to have 5 more. That means all 8 classes, including these 3 existing classes, are going to have a list of 8 of these things that I have highlighted, right? 1 for each type. Okay. It's easy, it's time consuming, and it's error prone. I'm trying to think, symbol and the constant class, both of them together, I want to say it took me a couple hours, and you've seen I'm pretty good with my editor, so it is time consuming to do. And it is error prone. I did spend some time debugging. When you get everything in place, you haven't done anything with GPL.y, none of that, you should be able to compile, right? The constant.h should be included in various files, and it should compile down without error. It should catch all the syntax errors anyway if you try to build this project after throwing all this stuff in there. I did go ahead show as an example what the rectangle class looks like. Note that it was a little bit weird with the integer double string in that, for instance, I don't know, integer, if you ask for it as an integer, it's going to return the data fine. If you ask for it as a double, it's going to return the data fine. If you ask for it to the string, it returns the data fine. Let me see, let me find double. That's going to be more interesting to look at. Right, so here, if you ask for it as a double or ask for the double as a string, you're fine. But if you ask for the double as an integer, it throws double, right? So if you're not able to make the conversion, you throw an exception. For all these game objects, everything throws an exception except when you ask for the correct type. And then, from experience, I got that confused sometime doing my search and replace. I'd end up throwing rectangle out of GPL type, or out of type. Make sure that you kind of mentally keep this one function different. It is not the same as these as functions right above it. So you need to do all that. You have variable evaluate. The variable class now not only manages inst double strings, it manages inst double strings and the 5 game object types. Also, animation block is thrown in here as well. I think I probably say that a little lower. We'll find out. Or I set it up above and missed it. You're going to have to update variable evaluate for the 5 game objects plus the animation block. Or maybe, I wonder if you have to do it for animation block. It says in there if I need to. So this just becomes a little bit more complex. If you're dealing with an array, that becomes a little bit more complex. Not that bad. All right. Now we can start playing with GPL.y. So this begins by saying, if you recall variable declaration, let me go into GPL.y. Here's my variable declaration. So that we do error checking and we create variables. When we create a variable, we are inserting a symbol into the, giving it to the table handler, and it's going ahead and putting it in the topmost symbol table. So we need to do the same for when we're declaring game objects. Game objects are not done in this declaration, they're done in the object declaration. So what it's saying here is that similarly, actions for object declaration production need to be written to add symbols for the game object types. As a refresher, we know what it's like to create an int, double, and string. This is what it's like to create some sort of game object. It presents a special challenge, as I say, because of this stuff in here. And let me go to the object declaration. So here's the version without not an array as a discrete type. That's what these two examples are showing. But you can also say triangle, my triangle, square braces 30 to create 30 triangles in an array. I'm not focusing on the arrays here, because what I'm trying to focus on this item, what item is this? Item 6, is this little bit right here, this parameter list or empty. Just like in variable declaration, you can have an optional initializer, but there is no initializer when you create an array of doubles. Here, when you create an array of game objects, there's no initializer, right? So the problem child is when you're only declaring a single game object and you're providing a parameter. And the issue is doing error checking. When there's a problem with a parameter, like you say, let me look at the example. So these are valid examples, but maybe I put the variable xyz here. That is a variable that doesn't exist as an attribute of a triangle, or any of them for that matter. So an error gets generated, and I don't remember the exact text of it, but it says something like xyz is not a declared parameter in my triangle. All right? And the key is that the name of the game object is part of that error message. Coming back here, by the time you reach this rule, all the parameters have already been processed. And so you have this weird situation, which is, well, how in the world can I process this and check its validity and complain that there's something wrong with it if I haven't even gotten to this part yet? Meaning this rule. And so there are a few ways around it. The way I chose that I think is fairly graceful is what we'll do is we'll build a linked list of these parameters, and we won't do any validating of them until we hit this rule. So by the time we hit this rule, what this will be is exactly what the name says. It'll either be a list of parameters, a linked list of parameters, or it'll just be empty. It'll be a null pointer if there's nothing there. Okay? And then what we can do is we can go ahead and in this rule we can do all the validation of the parameters, and after that we can go ahead and finish up with the object creation, assuming that there's nothing wrong. So it goes into a bit more detail on the strategy for doing that. It says what I just said. And probably the only kooky thing then about building this parameter list when I look at these examples is I'm going to be going through these parameters in this order. And I want to preserve this order, so what I need to do is I end up creating my list, throwing that in. and then I come across this, and I need to put this at the end of the list, right? And then I need to put this at the end of the list. So every time we add a new parameter, we've got to find where the end of the list is and go ahead and tack it on at the end, rather than making it the head of it. So here's what the suggested structure looks like from which we build our linked list. And we need to, actually, in order to understand all these perfectly, let's go ahead and follow this parameter list. Okay, a parameter list is either a parameter list or it's empty. We're not interested in empty, that's just a null pointer. All right. So this is what constitutes a parameter: ID, assign, expression. Coming up to the example, ID, assign, expression. Now the expressions aren't very interesting here, but you know that can be arbitrarily complex, right? This can say a times 100 divided by x times 2.0, and you can invoke any number of operators there. So it truly is an expression that sits there. So given that, when you enter this production, and you will, the parser is going to go parse, parse, parse. It's going to see that much of it. It's going to dump you into this rule here. And what you need to do is create an object of this type. The expression pointer is $3. The name is the dereferenced $1. Next, what's next going to be? Null pointer. And then we have a destructor. Actually, I think this is, I think that's all right. I need to think about this expression. I'll be thinking about that over the weekend and decide whether I need to delete that here as well. There may have been a reason why it's absent. All right. So we go ahead and we create the parameter here. That parameter is going to find its way right here. The very first one is going to find its way right here and become a parameter list. The second parameter we deal with is going to be this one. Yeah, let me go with this bottom one, it's more interesting. So this will be the second parameter. We will create a second parameter object from that structure. We will come up here, and here's that first one, and here's the second one. So what we need to do is we need to tack this one on the end of this, right? Let's actually write a little bit of code. Let me just call it FDSA. I like last, but that seems a little misleading because it starts at the head. Give me an expression. I want to keep looping until what is true. So as long as next is not a null pointer, then yeah, I'm doing this all in the same line, but let me go ahead and, for our eyes here, okay, when I hit where my cursor is, then I know that FDSA arrow next is null pointer. So what's my next line of code? There you go. And then finally, don't forget this, Now it makes more sense why I chose the word last. Because it ultimately ends up being the last one, and to its next I add the new one. What's this one? The very first one. You may not need that. That's kind of the default if you don't do anything, but it's nice to make it explicit. Once we start doing this stuff, you have to start worrying about the type and that union. We've got a new type now that needs to go in the union, so we're starting to pass those things around. So don't lose track of those. Those are like a distant memory now, aren't they? They slap you in the face once again. This is awkward for me to read it. At this point, GPL.y and the rest of the project is incomplete, but if you run make, it will build. That's what I meant to say. Okay? And that's what I will say by the time the weekend is over. So once you hit this point, then make sure everything's compiling fine. All right? And it walks you, so we're down here, we have to traipse it up here, and then ultimately have to traipse it up to the object declaration. So that's covering that, and then we have the please pause here. So I think there are a few hours of work here, and that'll get you a good chunk of the way through the project. Are there any questions? Huh? It is due, I currently have it due in a week and a half, so 2 weekends worth of work. This coming weekend to get to this point, and then during the week and the final weekend to finish up. Any other questions? Okay, so I have a lot of homework. You have some homework. We'll come back Tuesday and share our results.